Welcome back. In our last lecture we have started collision topic, and we have done the basic of collision, like the type of collision. It could be one dimension, two dimension, means like head on collision or what oblique collision. And then we learned is based on what conservation of kinetic energy. It could be what elastic collision where kinetic energy and momentum both are conserved, or it could be what inelastic collision where only momentum is conserved, right? Then we have done two important problems on this. One question they ask is what are the final velocities after collision, V1 and V2. They can be asked for elastic collision or inelastic collision. Both formula I wrote for you. Then the loss of energy during collision they will ask you, so that formula also we have done. And I told you that loss of kinetic energy during collision is very important, because I have discussed with you that the same formula will be in what again, fourth chapter, in capacitor, in inductor, and what our next rotation chapter, right? Okay, so today what are you doing? Let's do some problem based on those velocities. Okay, then we'll do some problem based on what, energy loss formula. Okay, so once more let me remind you what formula we wrote. Again I said, like maximum time in our exam, NEET exam, when I am talking, they have asked for what, elastic collision, those velocities only, right, where E term is not coming. E come for what, inelastic collision. So I am writing for elastic collision this formula again. So final velocity of first ball will be like this one, m1 minus m2 upon m1 plus m2 into what, u1 plus 2 times of m2 upon m1 plus m2 into what, u2. That's the final velocity of first ball, and this is for second ball, m2 minus m1 upon m1 plus m2 into u2, 2 times of m1 upon m1 plus m2 into what, u1. So these formulas are for what, elastic collision. In elastic collision, you know that here E will come and here 1 plus E come. Instead of 2 it becomes what, 1 plus E. So E value will be given to you, coefficient of restitution will be given to you. You have to put in this formula that. Okay, yeah. So doing some problem based on this, some important problem. Look here, let's see first problem. Suppose two balls are there of equal mass and they are moving. When they collide, then what will happen, that you want to see. Okay, first let's see two ball of equal mass. Okay, and how they moving, you can say first case moving in same direction, you can say same direction, or let's say first moving in opposite directions. Okay, it means I am trying to say like this one, this is one ball, this is another ball, this is a mass m1, mass m2, this ball is moving this direction with velocity u1, then that ball is moving that direction with velocity what, u2, and mass I am saying same only, this m1 of mass m1 both mass are what, equal. Okay, yes. So how they are moving, they are moving in what, in opposite direction. First case you are talking, then we will talk about same direction, then one body will be at rest, one body is moving, all will talk slowly. So this is before collision, this is the situation. Now we are interested when they collide, then what happened to their final velocities. Okay, so we will use these formulas. Okay, so what is final velocity? Look here, v1 will be what, look at this term, m1 minus m2, m minus m, that term becomes what, directly 0, correct? So let me write once more, should not confuse, m1 minus m2 upon m1 plus m2 into what, u1 plus, this is a formula, m2 upon m1 plus m2 into what, u2. Let's put values here. So when you put values here, mass is what, equal similar bodies, so m1 minus m2, this term will be what, 0 directly. Okay, this term m2 means 2 times of m by m plus m, and now it's very important, what is u2? u2 is u2 magnitude, but its direction is what, opposite. That direction we are calling positive direction. Okay, so this ball is moving the opposite direction, so here you have to put what, minus u2, be careful. Okay, so 2m by 2m get cancelled, so what answer we are getting, simply minus u2. It means we are getting v1 is equal to what, minus u2. That's the velocity of the first ball, final velocity of the first ball, which is coming minus u2. I will explain the meaning of this little later. Let's first find v2. So how v2 will look, formula is what, m2 minus m1 upon m1 plus m2 into u2 plus 2 times of m1 plus m2 into what, u1. Same thing. Okay, m2 minus m1, both are mm, so this term again becomes 0, right? So we got 2m upon m1 m1 plus means both are forget this, okay, into what, u1 that direction we are calling positive, so that direction is what, negative, right? Okay, so answer is coming simply u1, means v2 what we are getting what, u1. Now give attention and understand. Answer they can write as a numerical answer, means some values will be given to you, they can ask numerical answer, or they can write option in words also. How they will say? If you give attention, this ball was moving in positive x direction, that ball was moving in what, negative x direction with velocity u1 and u2. After collision what happens? Look, what's the velocity of the first ball? It's coming minus u2. It means what? The velocity of this ball is equal to the initial velocity of that ball, and minus means that ball will rebound and moves in that direction. This is before collision, and after collision what happening? How they are moving? Give attention. That ball moves in that direction with what velocity v1 is equal to what, u2. Minus means what, that direction, and this ball was moving that direction, this start moving in that direction with velocity v2 is equal to what, u1. Look at v2, what's the velocity of this ball? u1. It becomes velocity of that ball and it moves in one opposite direction. So when the balls are moving like this way, after collision they moves in opposite direction to each other from the initial direction, right? And their velocity get what, interchange. The velocity of this ball is the initial velocity of that ball, and the velocity of this ball is the initial velocity of that ball. Velocities get what, interchange. So how they write in words? After collision what happened? They move in opposite direction and their velocity gets what, interchange, right? So this way will you ask some numerical way also, they can ask, they can give some value of masses and velocities, you can find no problem, it's a simple formula, right? Or they can ask directly like this way itself. Two balls are moving towards each other of equal mass with different velocities. When they collide, their velocity will get interchanged. This ball will having the velocity of that ball, and that ball have the velocity of the other ball, right? The velocity will get what, interchange we say, okay? And they moves what, in opposite direction, okay? This is what when they are moving towards each other, like okay, towards, or you say in opposite direction, correct? Suppose you talk about this case. Let's keep one ball at rest, okay? Two ball of equal mass again, okay? And one ball is saying at rest, okay? So one ball is placed at rest, other ball comes and hit, then what will the final velocity is? Let's check it. So this is the initial case, this is a ball of mass m and moving with velocity what, u1. This ball of mass m2 but u2 is what, 0, initially at rest. This is the initial situation. Now we are interested in knowing what will their final velocities after collision. So let's write formula again. v1 is what? So let it repeat the same formula, m1 minus m2 upon m1 plus m2 into what, u1 plus 2 times of m2 upon m1 plus m2 into what, u2. Okay, let's see what happens. So again this term is what, 0. Why 0? Because m1 minus m2 both mass are what, same we calling, right? So 0. Now look at this term. This term also 0. Why? Because directly u2 is 0. The velocity of this ball is what, 0. So this term also becomes 0, means v1 simply equal to what, 0. Okay. Let's check about v2. What happened to v2? Formula is what, m2 minus m1 upon m1 plus m2 into u2 plus 2 times of m1 plus m2 into what, u1. Here again this term is what, 0, because m1 minus m2 is 0, or you say u2 also 0. Okay, look at the second term, okay, this term, 2 times of m upon m plus m into what, u1. So this becomes what, u1, or v2 becomes what, u1, correct? Now one ball placed at rest, one ball come and hit of same mass, then what will happen? The final velocity of this ball becomes what, 0. This ball becomes what, stationary, and this ball start moving with the velocity of that ball. Again you see that velocity get what, interchange, like here also velocity got interchange. Yes, here also what happens? Velocity of balls after collision, right? What happened? Gets what, interchange. Same thing happened, right? The first ball, this ball was at rest. After collision, this ball becomes at rest and this ball start moving with the velocity of that ball, right? correct? So velocity get what? Interchange. Okay, let's talk about some more cases. Suppose same question I asked you for what? They moving in same direction, then what will happen? Two ball of equal mass moving in same direction, suppose. Like here I talk opposite direction. Two balls were like this way, and this is the velocity u1, and this also moving in same direction with u2, this mass m, this mass m, correct? Then we want to know what is the final velocity. So that direction we are calling positive, so both velocities are going positive direction. They will collide first only when if u1 is more than what u2, otherwise they will not collide, right? So u1 is, suppose u1 is more than u2, means this is moving faster, so it will hit that ball. After collision what happens? Okay, look here. So formula I am not writing again, look at this formula only. Okay, in this formula again this term will be 0, m1 minus m2 is what? 0. Okay, second term, okay, this term 2m upon what? Again m plus m into what? u2. u2 is what? Here, that's u2. Okay, correct. So this get cancelled. If you see carefully, v1 is simply coming what? u2. Okay, that's okay. Let's talk about what? v2 term. What is v2? Let's write this formula. Again this term will be what? 0, because m2 minus m1 same as 0. Now look at this term. Give attention to this term. This becomes what? 2m up by m plus m into what? u1, or this becomes simply what? u1. So v2 is coming how much? u1. So look again, if you see carefully, the velocity get again interchange, right? So any case we talk like two ball moving in same direction, opposite direction, or one ball at place race, what will happen always? Their velocity will get interchange if their mass were exactly equal. This happens only when the mass are what? Same. Mass are different, you will put in the formula like this is given m, this is given 3m, you put here properly 3m minus m and calculate some numerical answer. So this is very popular. So if two bodies of equal mass, they are colliding like this way or same direction, or one body at rest, what is happening always? Their velocity get what? Interchange, that's for sure. So here you see that in that what happening in this case, their velocity get interchange, but they moves in opposite direction also. Two ball were coming like this way, after collision they moves like this way, right? Yeah, direction also get changed. Here velocity get interchange, here also velocity get interchange. Here direction will not change, they keep moving in same direction only, right? But velocity get what? Interchange. Okay, yes. Let's talk few more special case now. Suppose you have this case that one ball is very big and other ball is what? Small mass, means negligible mass. Suppose two ball of m1 is very big than what? m2. Correct na? One mass is what? Very big, then what happens? Suppose this is a ball of mass m1 and this is a ball of mass m2, and this ball is moving with velocity u1 and this ball is at what? Rest. Okay, first I call rest. Okay, this is a ball of very big mass and we said m1 is very big than what? m2, and this is I am saying initially at rest. Okay, in this case what will happen? What happened after collision? When this ball collide with that ball, what happened to their velocities? Okay, very interesting. A very big thing comes and hit a small thing, then what happened to the velocities? You can visualize it. Okay, let's write formula and see what happens. So what happened to v1? Formula is what? m1 minus m2 upon m1 plus m2 into what? u1 plus 2 times of m1 plus m2, correct, into what? u2. Okay, I wrote little wrong here, so m2. Okay, now let's see. So what is given? First, mass are different. One mass is very big as compared to what? Other mass, and this is ball is at rest. So look at this term first. m1 minus m2 is what? m2 is very small. m2 is very small is what? Negligible, like, right? So in this term m1 minus m2, like very big minus very small is what? That doesn't affect. So this we can neglect. Same here also, m1 plus m2, so we can neglect. So m1, what are we getting here? Simply m1 by m1 into what? u1 means what? u1, that's all, right? And here m2 is what? Very big, so we're making it what? 0, right? Now we're neglecting this m2. Okay, by m1 plus m2 again making 0 into what, u2 is already at what, 0. So means this time is coming to 0 simply I am saying. So v1 is coming what, simply coming what, u1. Okay, let's check v2. What happened to v2? v2 formula is what, m2 minus m1 upon m1 plus m2 into u2 plus 2 times of m1 plus m2 into what, u1. Look at this term, what happening. Okay, this time I am writing directly 0. Why 0? Because u2 is what, 0, so forget this. Only this time is remaining 2m1. 2m1. What is m1? That big mass. Okay, 2 times of m1. By m1 plus m2, m2 is again we saying what, 0. By m1 into what, u1. So if you cancel this, what are we getting? We are getting v2 is simply equal to 2 times of what, u1. Now what's the meaning of this? Initially this ball was moving with velocity u1, this was at rest, okay. After collision what happened? The final velocity of this ball is what, u1 only, no change. This is a very big ball, it colliding a small ball, so the velocity of big ball is not affected at all. So this velocity of this ball will remain same only, whatever initial velocity, that's final. But this was at rest, so big ball hitting this small ball, what happened? The velocity of this ball will move at what velocity? Double of the velocity of this ball. This ball was moving at 10 meter per second, then after collision this ball will move at what, 20 meter per second. The velocity of the second ball, small ball, becomes double than the big ball, okay. It start moving, that ball start moving, but the velocity of this ball will not be affected, remains same only, no change, right? Okay. Now suppose what other possibilities we can have here? This ball also may be moving in this direction or that direction, doesn't matter, right? Correct? Yes. Or suppose we make it opposite. Suppose we write this case, 2 ball of m2 is very big than what, m1. I make this ball very big and this ball as what, small, right? Then how they look? So I say like this is what, one ball of mass m1, another ball here what, m2, correct? And again let's say this is placed at rest, this is moving with velocity what, u1 in this direction. This is a small mass, that's a big mass, okay? Yes. So means in this case the big ball was moving and small ball was stationary, right? Here I am saying the big ball is stationary and small ball is moving and hitting this. Then after collision what happened, that we want to know. Okay, let's see. So what will happen? Your formula v1 is equal to what? m1 minus m2 upon m1 plus m2 into u1, 2 times of m2 upon m1 plus m2 into what? u2. Let's write formula. Okay, now see. Okay, look at this term. Who is very big? m2 is very big. So look here, m1 we neglect, this we make 0, we make 0 here. What are we getting? Minus m2 upon m2 into u1. That becomes what? Minus u1, right? Yes, minus m2 upon what? m2, that becomes minus 1 into u1, and this term is what? Directly 0 because u2 is what? 0, okay. So this is the velocity of this ball, so v1 is coming how much? Minus u1, okay. That's the velocity of that ball. Now calculate v2 also. So how v2 will look? m2 minus m1 upon m1 plus m2 into u2, 2 times of m1 plus m2 into what? u1. Let's check this equation. This term is directly 0 because u2 is what? 0, okay. Velocity of this ball is 0. Now look here, 2m1. m1 is what? The mass of this ball, which is what? Negligible, in making 0. When you make this term 0, everything becomes what? 0 only, right? So v2 will be equal to what? 0. Okay, now let's understand meaning of this. Okay, let's make it very small so it doesn't confuse. So this small ball moving with velocity u1 come and hit this ball, big ball, which is stationary. Then after collision what will happen? What's the velocity of this ball? This is what? Minus u1. This ball after collision rebounds, direction coming what? Negative. It was moving this direction, we calling positive, so it becoming answer what? Negative means this ball will rebound with what? Same velocity. Small ball, this ball will rebound with what? Same velocity, right? Rebound with same velocity after collision, right? And what happened to the big ball? Big ball will not move because small ball is coming and hitting a very big ball. Big ball will not move, so it doesn't move. Yes, this remains what? Stationary. Remains what? Stationary. Correct? Yes. So hope you understanding this, how to use the velocities formula to give the answer of what final velocities after the collision. So all the example that I have done here based on what elastic collision. If inelastic is there, then that E term will come in the formula. So as per I remember in NEET exam they did not ask those questions yet, but they can ask you. So in inelastic collision E will come here like m1 minus E times m2. Here instead of 2 it becomes what, 1 plus E, right? So E value will be given to you. If it's an elastic collision, you can put in the formula, and same way you have to answer. Okay, mass is given, same mass, big mass, small mass, or m, 4m, any mass can be given. Just you have to use simply the formula to answer these questions. Okay, we're doing few more problems based on the finding the final velocities. So here I took 3 examples. So the first example will be based on what, your elastic collision. This is the example of what, elastic collision, and this will be what, based on what, inelastic collision. And this is the example of what, perfect inelastic collision. So all 3 types of example I took here, and already I told you in perfect inelastic collision what happens, the bodies get what, stick together and they move. Okay, let's talk about the first problem. There is 0.1 kg ball makes an elastic collision with a ball of unknown mass which was at what, rest. Second ball is given at rest. If the 0.1 kg ball rebounds with 1/3 of the initial velocity, find the mass of the second ball. M2 we have to calculate. Let's draw it, how it looking. Initially there were 2 balls of mass m1, m2. m1 is known, m2 is unknown. Okay. Yes, so this ball was at rest, u2 was 0, and this was moving with velocity u1, say like this. This is the initial, okay. Initially, this is what happening. After collision, what is given? This is moving with velocity v1, that's moving with velocity v2, this mass m2, m1. So they said that if the 0.1 kg ball rebounds with 1/3 of the initial velocity, this u1 initially we calling, let's give some name, is equal to what, u. Okay, this is initial velocity u. Then the final velocity of this ball is given what? Is given minus u by what? 3. 1/3 of the initial, it rebounding first. Rebounding means what? Direction changing. I am saying initially this ball was moving in positive x direction. They said rebounding means it moves what, in negative x direction. Velocity will be first negative. So final velocity is given of this ball is given how much? 1/3 of the initial means u by 3 and negative because rebounding. Okay. So final velocity of this ball is given to us. And they are asking what's the mass of this body. So final velocity of this ball we know, so we can write the final velocity formula, this formula for this ball. Let's write it, what will happen. Okay, let me write it here. So I am writing it here, what will happen, look, v1 is what, m1 minus m2 upon m1 plus m2 into what, u1 plus 2 times of m2 upon m1 plus m2 into what, u2. Let's solve this. So first thing, v2 is u2 is directly given 0. This ball is initially what, 0. So this term is what, directly 0. u2 is 0. Okay, that's one thing. Then what is given to us? v1 is given. v1 is given how much? Minus u by 3. This is given. Then m1 also given. The first ball 0.1 kg minus m2 we have to find by 0.1 minus plus m2, and u1 is what, u. Initial velocity of this ball we call it what, u symbol, right? Final velocity says rebound means negative direction, rebounding means opposite direction, and velocity is given 1/3 of the initial. I wrote u by 3. Okay, let's cancel. U get cancelled here. Let's cross multiply these numbers. So minus 1 by 3 and these numbers. So this goes here. We got minus 0.1 minus m2 is equal to 0.3 and minus 3 m2. This number will come, right? Cross multiplying. Okay. Yes. Okay, let's send the same term, m2 term on this side, this term on that side. So when this term come, positive 3 means become 2 times of m2, and this other side become what, 0.4. Minus 0.1 coming here, 0.3 plus 0.1 is what, 0.4, and this goes that side, becomes positive 3 m2 and negative m2. So this is what your m2. How much m2 you getting? 0.2 kg. This is the mass of that second ball, right? Mass unknown, velocity is unknown, you can find using this final velocities formula. So this is an example of what? Elastic collision. Okay, done. Let's move to the next problem. which is based on inelastic collision. Like here they did not mention about E. They said word also like elastic collision. Sometimes they don't say. Then if they're not giving that coefficient of restitution, means what we are talking about elastic collision simply. Okay. Okay. So a ball of, let's see this question, a ball of 2 kg mass moving with velocity of what 5 meter per second directly collide with another ball of mass 3 kg moving in the same direction. Okay, with a velocity of what 4 meter per second. Find final velocities of the ball if E is given what 2 by 3. E given, coefficient of restitution given means what is an inelastic collision first, right? And we have to calculate what final velocities here. So you have to use our proper formulas. Okay, so all are given, first ball, second ball, and their mass is given, their velocities all are given. So how they are moving initially, let me draw here. There is a ball 1 of mass m1, say there is a ball of mass m2, and they are moving in what same direction, both ball are moving in same direction, u1 and u2 like this. Directly collide with another ball of mass 3 kg moving in the same direction with velocity of what 4 meter per second, that moving with 5 meter per second. Velocities are known, masses are known, we have to calculate only final velocities. So let's write formula. What is formula of V1? Look at this formula, what change, only E comes like this, m1 minus E times of m2 upon m1 plus what m2 into what u1 plus, instead of 2 what you write 1 plus E by into m2 upon m1 plus m2 into what u2. This is the final velocity of the first ball. So let's calculate it. All values are given to us. m1 2 kg, I wrote here 2 kg, minus E time, E is given 2 by 3 into m2 is how much given 3 kg, okay 3 kg by. So if you see that, no need to write next term, because if you see that 3 get cancelled here, then 2 minus 2, this term will become 0. But if you want to put, you can put 2 plus 3 into velocity of first ball is given what 5. So this term will become directly 0, okay, plus 1 plus E, 1 plus 2 by 3 into m2 is what 3 kg, okay 3 kg divided by m1 plus m2 means 2 plus 3 into velocity u2 is what 4, and all are positive, all are moving in positive x direction, we are saying 4. So we have to solve, this is directly 0, that term, right? Okay, so how much this become? This become what 5 by 3 into 4 by what 5, 3 get cancelled, 5 get cancelled, we are getting what 4. So this answer is coming 4 meter per second. So this answer is what V1, we have calculated V1 which is coming 4 meter per second. Same way we have to calculate now what velocity of the second ball. V2 also we have to calculate. So let's calculate it here. What is V2 formula first? Okay, same way, m2 minus E times of m1 by m1 plus m2 into what u2 plus 1 plus E into what m1 upon m1 plus m2 into what u1. Let's calculate this, okay. m2 mass of the second ball which is given what 3 minus E is given what 2 by 3 of the mass of the first ball which is given what 2 kg. So if you see that this term also becomes what 0, 3 get, no this doesn't come 0, sorry, yeah, not coming 0, okay, divide by m1 plus 2 plus 3 into velocity of the first ball. What is the velocity of the first ball? u1, thus we wrote what 5 there, okay 5, correct, okay, plus next term 1 plus E, 1 plus E means 1 plus 2 by 3, I am directly writing 5 by 3 into what u1. I wrote little wrong here, I should write here u2, u2 was here 4 actually, u1 will come here by 5. So if this get cancelled, and if you solve this number, how much it will come? This becomes 4 by 3, and this becomes what 9 minus 4 means 5 by 3, 5 by 3 divided by what 5, and there is one more 4 here. So this get cancelled here. So I think we are getting here, this will be getting 4 by 3 that term plus this term which is what 5 by what 3. So this we getting what 9 by 3. Now some calculation mistake happened here. Let me clean this. Let me check once more. I think I did some calculation mistake. So this formula is okay. M2 is what? Second mass 3 kg. I wrote correctly only. Then E times of M1, E is given 2 by 3 into what 2, yeah, that's also okay. Then total mass, and here coming what U2, U2 is what 4, that's also okay. Then second term 1 plus E, that's what 1 plus 2 by 3 means 5 by 3, okay, into M1, here I did mistake, so one term I missed here, M1, what is M1, 2 kg into what velocity what, which is what U1, that's 5 I wrote here, so this mistake happened here, otherwise okay. So let's see now, so again this becomes what 4 by 3, this becomes 9 means this becomes 5 by 3 into what 4 by what 5 plus, so how much this becomes 5, and so this becomes what 10 by what I think 3, 10 by 3, 5 goes here, this is coming 4 by 3 plus 10 by what 3, so this becomes 14 by 3 is answer coming meter per second, means it becomes 4.6 something, right? Yes. So this is what example of what inelastic collision, where coefficient of restitution will be given. So this is your right correct formula. Yes, that's formula for what elastic collision. Okay, third type of collision now we are talking, which is more simple. It's called perfectly inelastic collision. Here after collision what happens, bodies get what stick together and they moves what together. Now they become what one body. Okay, yeah. So look at the example. They said a body of mass 2 kg is moving with velocity of 3 meter per second collide with a 1 kg body moving in what with velocity of 4 meter per second in opposite direction. Okay. After collision, the bodies stick together, find the common velocity. So give attention here. Two balls are given. This is before collision. This is a 2 kg body M1 and moving with velocity of what 3 meter per second. Let's say in that direction. That's what your U1. Then this ball is moving in opposite direction. U2 is what opposite, and how much 4 meter per second. They're saying mass of this body is given what 1 kg. They're saying two bodies are coming like this and they stick together because of perfectly inelastic collision happening. What's the velocity after collision? So in this type problem, you don't need to use this formula. It's very easy. Directly write what momentum equation. So remember that when you talk about these type of equations, perfectly inelastic collision where bodies get stick together, we don't need to write all these formulas. Okay. You can write actually, but it's complicated. You can write this formula, miss where you wrote these formulas. Okay, you can write this, but this waste of time because okay, suppose you want to use this formula, what will happen? Your E value is what simply what your 0. That's all. You will get answer from here. But better way is what always write conservation of momentum. Initial momentum is equal to final momentum. Okay. So after collision, what happens? They stick together. It becomes 2 plus what 1 kg. This is one body moving with some velocity v. So initial momentum is equal to final momentum. What is initial momentum? Momentum of this ball is what 2 into 3, and this ball moving in opposite direction. So minus how much 1 into what 4. So that's the initial momentum. 6 minus 4 means what 2. You're writing what conservation of the momentum in this type of example. That's more easy way to answer. You can use this formula also, your choice. But I'm saying write conservation of momentum, that becomes very simple. So momentum of this ball is what 2 into 3 6. Momentum of that ball is 1 into 4, and they are moving in opposite direction. So angle is what 180 degree. So answer becomes what A minus B always. This also we writing by vector rule only. Momentum sum of this plus sum of this, like this vector rule we writing, but you know that angle is what 180 degree. They are moving in opposite direction. So when you use our formula vector addition, like R is equal to root A square B square plus 2AB cos theta, cos 180 means answer become directly A minus B. So I wrote like here A minus B only. Okay. This is initial momentum should be equal to final momentum. What is final momentum? Total mass became 3 kg into velocity v. This is final momentum should be equal to initial momentum 2. So v becomes what 2 by 3 meter per second. That should be your answer. Done. Correct. So perfectly inelastic collision, what you write? Write conservation of momentum to find the final velocity, because there is only one velocity. There is one body after collision, right? Not v1 and v2. So forget this. Just write what? This much only. Okay, that will give the correct answer. Conservation of momentum you will write. Okay, so these are the problem based on what? Velocities, calculating the velocities, right? Now we will do problem based on what? Some energy formula. Okay, energy loss. Yes. So now we are doing the problem based on what? Energy loss or energy in the system. Okay, so mainly the formula we use is our energy loss formula only, which is what del is what half m1 m2 upon m1 plus m2 u1 minus u2 square, or if it's an inelastic collision given, then you can write here one more term 1 minus e square. Okay, generally if they have asked our exam, they have asked this much only. Okay, yeah. Okay, look at the problems. Two balls of masses 2 kg and 3 kg moving with velocities of 4 meter per second and 6 meter per second respectively in what opposite directions collides. Find the percentage of energy lost in this what collision. What percentage of energy is what lost in this collision? So look at the two balls are given. This is 2 kg ball and another ball is given 3 kg ball. They are moving in opposite direction with what velocity is 4 meter per second, and this is moving like that way with 6 meter per second, and we have to calculate what is the percentage of the energy lost. Okay, let's calculate how much energy is lost daily. We are writing formula half mass 1 2 kg, directly that formula I am writing m2 3 kg by 2 plus 3 done. Then what will come here, u1 minus u2 or u1 plus u2? Look here, u1 we calling that direction which is positive, then that ball is moving this direction, u2 will be negative. So extra minus we will put here, it becomes u1 plus u2. So it becomes what, how much, 4 plus 6 and what square of this, not minus, give attention there, okay. So 1 by 2, okay, let's solve this number, this get cancel here, we getting 3 by 5 and this become 10 square means 100, so 5 goes 20 times, this becomes what, 60 joule energy finding, 60 joule energy is what lost. So they are asking that what is the percentage of energy is lost. If they are asking just how much energy lost, that's the answer, 60 joule. They are asking what is the percentage of the energy lost. So you have to calculate what is the initial kinetic energy. What is the initial energy? Okay, look here. How much initial? Half mv square of this body. Half m is what, 2, v square means become what, 16, plus half mv square of this body, mass is what, 3, v square means what, 36. So this becomes what, 16 joule, and this becomes what, 18, right? Okay, 18. So 56 you write here. So how much this becomes? 76 and 66 plus 6. So becomes what, 72, okay, joule. Okay. Now let's see. This was your initial energy, kinetic energy. This is loss given. So what's the percentage of energy is lost? You write del lost by original into what? 100. 60 by 72 into 100. Okay, that will be your answer. Some percentage answer will come if you calculate this number. Suppose you divide by what? 12. 6 times, 7 times. You're getting like something 600 by 7. So around 80, like this goes 56 4 times. So you say something like that will approximate answer will come, okay, percentage 85 point something will come, okay. Yes, that much percentage energy is what lost, okay. Yes, okay, let's move on to the next problem, which says that a ball is dropped from a height of 10 meter and rebounds from the ground to height of what, 2.5 meter. Calculate the percentage loss of kinetic energy. So understand the question, we are dropping a ball from some height. This is the height given, initial height, which is given 10 meter, but after rebound it goes to what height? Only just 2.5 meter only. So because of some energy lost here, the impact is what, inelastic collision, so energy is lost at the ground, so it rebound to what, less height, right? So they are asking what percentage of energy is what lost. So you have to calculate initial energy at this point, we have to calculate final energy at this point, then we have to find loss, then they are asking percentage loss, okay. Okay, what is the energy when this ball hit here? What is the initial kinetic energy? Okay, you can calculate here or you can calculate here by conservation of energy, because at this point we have potential energy, right, and this we have only kinetic. So kinetic at this point should be simply equal to the potential energy at that point. That point we have only potential, at that point we have only kinetic at the ground, right. So kinetic at this point initial is equal to potential, which is what, mgh, okay. M we know, okay, just write mgh only, okay, this much. And energy, kinetic energy final is what, means at this point is what, while starting rebounding final, that will be potential energy at this point again, right. Kinetic energy at this point is equal to potential at that point, again is what, mg, let's equal h1 here, equal h2 here, okay. Now what is loss? Loss is what, difference, mg h1 minus h, that's a loss. So what is the percentage loss they are asking? Del E, percentage what, del E by E into what, 100. Loss is what, mg h1 minus h2 by mg h1 into what, 100. Okay, mg, this thing get cancelled. H1 means what, 10 minus h2, how much rebounding, 2.5 by total initial what, 10. So this become what, okay, into what, 100 to convert into percentage answer, right? So this becomes 7.5 by 10 into what, 100. So that becomes 75% simply. So 75% of energy is lost when you drop a ball from 10 meter height, but it rebound to what, just 2.5 meter only. Okay. Okay, let's see next problem based on spring and block. So for the given situation, if the collision between the blocks A and B is perfectly what, elastic collision, means what, energy conserved and what, momentum both are conserved. Then find the maximum energy stored in the spring. They are asking what's the energy stored in the spring, we have to calculate. Okay. Okay. So the energy coming from this and momentum coming from this block A should be what, equal to what here, because momentum is conserved and what, kinetic energy also conserved. So let's first use conservation of momentum principle. You're talking about conservation of momentum. Okay. Momentum we are talking. Let's calculate what, at when this ball impact this, at what speed they start moving, what are the velocities of these blocks V. So writing conservation of momentum, what is the initial momentum of that block A? So I'm saying like momentum of block A should be equal to momentum of block B plus momentum of the block C. So what is the momentum block A? 3 into 2. Okay, what is the momentum of block, this block? 3 into some velocity V, 6 into velocity V. They will move say with same velocity. Okay, they are connected by a string. Okay, so from here you see that V is nothing but what, thus 3 into 2 by, this becomes what, 9. So this becomes what, 2 by 3 meter per second, and this is the velocity of these two blocks. Okay, after collision. Now this is a conservation of what, momentum we wrote. Now write conservation of what, kinetic energy, conservation of energy or kinetic energy. Okay, energy, whatever energy in that ball should be energy into three things, what, this block, that block and spring also, right? Okay, less spring energy you can call ES. So what's the energy of that block, block A? Like I'm writing energy in block A should be equal to energy in block B plus energy in block C plus what, energy of the spring. This energy is given to what, these three things. Okay, what is the energy of the block A? Half mp square, half. Mass of is what, 3 kg and velocity is what, 2. So that becomes 4 is equal to energy of the block B, half, mass is 3 and velocity we wrote here 2 by 3 and what, square, plus energy of that block is 1 by 2, mass 6, 2 by 3 square plus energy of the spring. So how much this comes? This becomes what, 6 joule. Okay, and how much this comes? 1 3 goes here. So what is remaining? 1 3 goes here. This is 4. 1 also can cancel. So 2 remaining. So here remaining what, 2 by what, 3. Okay, 2 by 3 remaining here, plus what is remaining here, this is what, 3, 1 3 get cancelled here. So here also remaining what, 2 by 3 plus ES. So this is ES simply becomes how much, that's 6, and this becomes what, okay, I think some calculation went wrong here. Let's check it once more. This is becoming 4 by 3, right? Let's check here. So this becomes 4 by 9. I'm saying 3 get cancelled here, 1 3 is remaining and 1 2 gets 2 by 3. That's looking okay. Here, okay, here I did calculation mistake. So look here, 2 goes 3 times, 1 3 get cancelled, coming what, 4 by 3 here. 4 by 3 means this becomes 6 by 3 means become 2, 6 minus 2. So what is the answer of this question? 4 joule is the energy stored in this spring, right? So these were the problem based on what? Energy problem, right? So after this we will move to the our second type of collision, which is called oblique collision, or what, in 2 dimension. Here we are writing like conservation of momentum just in one direction, because balls are moving along a straight line, right? So you are writing only one direction, like x direction. Now bodies will move in what, 2 dimension. So you have to write momentum in x direction, momentum in y direction. Then we have to use same principle to give the same answers, like what are the final velocities, what is the loss of energy. Okay.